In this video, we will look at what makes quadratic functions belong to the same family, and then we will use characteristics of one member in a family of quadratics to determine the equation of another member in the same family. Let's start off by looking at the graphs of four quadratic equations. Each of these equations are written in standard form, so we are able to identify the direction of opening by looking at the a value and the y-intercept by looking at the c value. These four graphs are all different from each other. Three of them open upward because there's a positive a value. However, the a values are different, meaning they have different vertical stretches. All of the c values are different, so they all have different y-intercepts. But something that they do have in common is they all cross the x-axis at the same place. So they all have the same zeros. The first zero is when x is -6, and the second zero is when x equals 1. And as the x-intercepts are all the same for these four quadratic functions, that means the axis of symmetry will also be the same for the four quadratic functions. Here I drew the axis of symmetry, and it cuts each of the graphs in half. So this means that the x value of the vertex on each of these four quadratic functions are the same. So when we are asked, what do these graphs have in common? We can say the x-intercepts, also known as the roots or the zeros, and the axis of symmetry. So how do the graphs differ from each other? They each have a different a value. They each have a different c value, which is your y-intercept. The direction of opening is not the same for all of them. Three of them open up, one opens down. And the x-coordinate of the vertex is all the same, but the actual coordinates of the vertex is different. So we can see the vertexes are different on each of the graphs. So to make a group of parabolas a family, they must share a common characteristic. That characteristic could be the same zeros or x-intercepts. It could be the same vertex. It could be the same, they all have the same y-intercept. In this specific lesson, we are looking at when quadratics have the same x-intercepts or zeros or roots. This idea of having a family of quadratic functions can apply to any functions that you will study in this course. So when we first looked at the graph above, the equations were written in standard form. So we were only able to identify the direction of opening and the y-intercept easily. Here, those same four equations are written in factored form. So now looking at this form, we are able to identify the x-intercepts. If we notice, each of these factors have a different a value. The second equation has an a value of 1, but they all have the same factors. When they have the same factors, that will mean they all have the same x-intercepts. Remember, when you're trying to solve for the x-intercepts, you set y equals to 0, and then you take each factor and set that equal to 0. So x equals -6, and the second factor, x minus 1 equals 0, so x equals 1. So the x-intercept should be -6 and 1, which they are, which we saw already from the graph. Here it asks, what is another function that could belong to this family? All of these family members share the same factors. So I am going to steal those factors for my new family member, x plus 6, x minus 1. So my new family member also shares that characteristic. However, I need to come up with a new a value to make it a different family member. So the same factors make it a part of the same family, but to make it a different member, I need a different a value. So I can't use one of the a values that have already been used because then I would be that family member. I also cannot use 0 because if we use 0, 0 times anything is 0. So you would just get y equals 0, which is the equation of a line, and would not have those same x-intercepts. So I'm not going to have 0 there, and I will just randomly choose -2. So there's many possibilities for this question. I can come up with the a value. Going forward, the question is going to give us more details where it will give us a specific a value. We're clearly able to see that all four of these graphs share the same x-intercepts. However, looking at the equations, we couldn't see that when the equations were written in standard form. Later, when we saw the equations in factored form, we could then see the factors were the same, which means the x-intercepts are the same. So we need to use factored form when solving problems to find equations of the same family. So factored form is y equals a, x minus r, x minus s. The a value represents its vertical stretch or compression, and it will tell you the direction of opening. The a value is different for each family member. Looking at the four equations in factored form, we can clearly see the a value is different. X minus r and x minus s are each the factors, and that is how we find the x-intercepts. Here the x-intercepts are r and s, and these are the same for each member of the family. It is important to understand why it's x minus r and x minus s. That is because r and s represent the x-intercepts, but when you put them into factored form, they change signs. So the minus is telling you to change signs. And we know that from looking at the above graph. Here the x-intercept is -6, but when it was in factored form, it's x plus 6, because it's -6 to give you a factor that will equal 0. And then when x is equal to 1, we write it as x minus 1. And that is why we have x minus r and x minus s. So I've just written here that in the above example, r is equal to -6, the first x-intercept, and s is equal to 1. And then when you put -6 into the equation, you're subtracting -6, so it becomes x plus 6. And when you put +1 into the equation, it's x minus 1, which is what we have. Just note that textbooks or other teachers might use different letters than R and S to represent the x-intercepts in factored form. We are now going to look at the idea of having families of parabolas to find the equation of a specific family member. To do this, we need the x-intercepts, and then we need another point on the parabola, and that will allow us to find that specific a value. There are two different ways the information could be presented, and so we're going to do two different equations. In number 1, it says the Gateway Arch in St. Louis is pictured here. The edge of the arch is the origin, and the arch has a width of 430 feet at the base. What would the equation of the arch be if the maximum height of the arch is also 630 feet? So this arch is sketched on this grid here. So the y-axis would be heights, and the x-axis would be the distance across. So here, if we were to sketch this, this would be the origin, which would be this point here. The width is 630 feet. So the other end of the arch would be this point here on the graph. And then the height is 630 feet. So now we're going this way. So that would be our y value. So our y value is 630. And then because of symmetry, we know that the axis of symmetry is at 315, half of 630. So that's how we get that point there. So we are going to use the information from this graph to actually determine the equation of this parabola. So step 1, we are going to use the x-intercepts to substitute in r and s into the equation. So here the first x-intercept is 0 and the second one is 630. So I will say r is equal to 0 and r is equal to 630. The general equation is a x minus r x minus s. So I don't know a, so I'm going to leave it as a, and I'm going to substitute in 0 for r and 630 for s. Remember to subtract each of those. X minus 0 is simply 0. So I'm going to simplify that. I'm not going to leave minus 0 there. So I'm going to write that as ax, x minus 630. So I don't need the brackets here anymore because I'm multiplying a by x. So I don't need the brackets around x because it's no longer a binomial. So my second step in this question is subbing in another point into this equation for x and y. So I'm not able to use the x-intercepts because I've already used those. but I clearly have the vertex, so I'm going to use that. So I'm going to substitute in 315 for x and 630 for y. So I get 630 equals a times 315 times 315 minus 630. So now that I have found the x-intercepts and substituted in a point into the equation, the only variable I have left is a, so I'm able to solve for that. So I'm going to simplify this right side and then solve for a. So my left side is just 630. My right side is a times 315 times negative 315, because 315 minus 630 is negative 315. So now I'm going to multiply these two numbers together and I'll get quite a big number. So 630 equals a times negative 99,225. And now to solve for a, I need to divide both sides by that number. So when I simplify, the right side is just a, because those two cross off, and my left side is negative 2 over 315. I just simplified this fraction, and it took me a while because these are big numbers, but I saw that one ended in a 0, the other ended in a 5, so I just kept dividing by 5 until I couldn't anymore, and then I think I divided by 3. But just keep reducing and reducing until you get the lowest fraction. And then finally, my step 4 is actually writing the equation. Now that we have this a value, you might want to highlight it, we are going to use that in the equation from above. So I'm going to write y equals negative 2 over 315 x minus 630. So that is the equation that models this arch. It makes sense that the a value is negative because it opens down. X is the first factor, and the second factor is x minus 630. So this is the equation. So now I can substitute in any x value and get a y value, and that will lie on that parabola. Back in step 2, we only temporarily substituted into a point because we knew these were coordinates that lied on the parabola. So we found the specific a value that made that possible. So now that we know the a value, we write an equation. An equation, we always need the x and the y because the y depends on the x. So if we substitute in that x value, we get the corresponding y value. The wording in question 2 is very different than the above question, and we set this one up a little differently, but most of the steps are the same. The information given in question 2 is different from above, so we will start solving this question a little differently, but then the later steps are the same. So in question 2, we want to find the equation of a parabola belonging to the same family as y equals 3x squared minus 9x minus 30, and it passes through the point 315. And then it says to leave the answer in standard form. In question 1, we were given the x-intercepts, or at least we could easily find them from the graph, and then we use those x-intercepts to write them in the factored form. In question 2, we are going to factor the equation that's given and write this in factored form. So we have the equation, y equals 3x squared minus 9x minus 30. We can see that there is a common factor of 3. So I'll factor that out to have 3 bracket x squared minus 3x minus 10. This is now a simple quadratic to factor. So two numbers that multiply to negative 10 and add to negative 3 are negative 5 and positive 2. So I have written this equation that was in standard form in factored form. So step 2 is I now want to take the factors from the equation that was given to me, but I don't want to take the a value. This a value is specific to this family member, and I'm finding a new family member. The only thing that is common, the common characteristic of my new family member, are these factors. So I'm not going to take that a value, and I'm going to replace it with a x minus 5, x plus 2. Be careful not to write 3a. The 3 goes away completely and it's replaced by a because you have a different family member, so it's going to have a different a value. So now the steps are similar to what we did in question 1. We have the equation in factored form, but we still need to find a. To do that, we substitute in another point into the equation and then solve for a. So in step 3, I'm going to write 15 for y equals a, and then 3 minus 5, 3 plus 2. So I'm going to solve for a in step 4. So 15 equals a times negative 2 times positive 5. So simplify within each bracket. And then I'm multiplying those together. So negative 2 times 5 is negative 10. So you might want to write that as 15 equals negative 10a, and then divide both sides by negative 10. So this fraction's a little bit better to solve or simplify. 5 goes into both, so it'd be negative 3 over 2 is equal to a. You could write this as 15 equals a times negative 10. Just be careful that you are not subtracting 10 here. You are multiplying with a, and we're used to the coefficients going in front of the variable. So now in step 5, we are going to take that a value and substitute it into the equation. So we get negative 3 over 2, x minus 5, x plus 2. So this is now the equation of this specific family member. So we took the factors or the x-intercepts from the first family member, and then we took a point that our specific family member goes through, and we were able to find the specific a value. So this question would be done if the question asked for it in factored form or didn't specify the form that it wanted. This is an equation. However, this question asked for it in standard form. So now that we have it in factored form, we need to expand it to then put it into standard form. So this requires an extra step because the question is asking us to do a little bit more. To do this, one way is to take the a value and multiply it with the first binomial. So you would get y equals negative 3 over 2x and then plus 15 over 2, and then you have to multiply that with the x plus 2. So this way would work. The problem with this way is now I have two fractions instead of just one, and then when I have to multiply that all out, I'm going to get 4 fractions. So what I think an easier way to do is to multiply the two binomials together, because neither of these have fractions, and then in the end just multiply by the one fraction. So we get y equals negative 3 over 2, and then I'm going to multiply x times x plus 2. I'm going to have to put this all in brackets, so I get x squared plus 2x, and then negative 5 times x, and negative 5 times 2. So negative 5x minus 10. And now I'm just going to simplify because I have like terms in the bracket. So negative 3 over 2, x squared minus 3x minus 10. And now finally, I'm going to multiply the a value of negative 3 over 2 to all three terms. So I get y equals negative 3 over 2x squared plus 9 over 2x plus 30 over 2. Remember, when you multiply fractions, you do not need common denominators. So all of these denominators are 1. So I just simply multiplied the numerators and multiplied the denominators. This last fraction can be simplified. The other ones cannot be, so I'm just going to leave them in fractions, not decimals. So I get negative 3 over 2x squared plus 9 over 2x plus 15. So these are both equations. They represent the same family member, and if you were to graph both on Desmos, you should get the same thing. Just one is factored form and one is standard form. If the equation asks for standard form, you still work with factored form the whole way because we're working with family members and I'm giving you the x-intercepts. So x-intercepts, we need the factors. So we work with factored form. Only at the very end do I go from factored form to standard form. In question 1, the form was not specified, so factored form was fine. Because I did not ask for standard form, I just left it in factored form. So leave it in factored form if the question doesn't specify or if it asks for factored form, and go this one step further if the question does ask for standard form.